In this video, we're going to look at two exam style questions involving upper and lower bounds. You can try the question first, pause the video, give it a go, and then you can watch my work solution. Okay, welcome back. So this question says a ball is thrown vertically upwards with a speed of v meters per second. The height h meters, which rises to, is given by the following equation. H equals v squared over 2g, where g is the acceleration due to gravity. Now these values have been rounded to 24.4 and 9.8. Now what we're going to do for a question like this is say, well, at the end of the day, all what matters is 24.4 has been rounded basically to one decimal place, so it has 9.8. So we know how to deal with this. We treat one decimal place as 0.1. So we do 0.1 divided by 2, which is going to be 0.05. So we work out the upper bound of 24.4. So we do 24.4 plus 0.05, which gives me 24.45, which is the upper bound. So the lower bound will be 24.4 minus 0.05, which will give me 24.35, and that's the lower bound. Now we can do the same for g. Well, g is 9.8, so the upper bound for this will be 9.8 plus 0.05, which is going to be 9.85. That's the upper bound. And then the lower bound will be 9.8 minus 0.05, which is 9.75. So now we've got the upper bound and lower bound respectively. The question says to write down the lower bound of g. We've already done that. That's 9.75. And then the next part of the question says the following. Calculate the upper bound of h, giving your answer correct to three significant figures. So here we need to be very careful. It's a divide question, so we need to be careful about the rules of upper and lower bounds. So it's going to be that the upper bound of h, so the upper bound of h is going to be the upper bound of v squared, so it's 24.45, which is the upper bound of v. We square this result and we divide it by 2 times the lower bound of g, which is 9.75, and we can work this out here. 24.45 squared divided by 2 times 9.75, and then we can get this to be 30.7 to three significant figures. Okay, so this question says Katie drove for 238 miles correct to the nearest mile. She used 27.3 litres of petrol to the nearest tenth of a litre. The petrol consumption is the number of miles travelled divided by the number of litres of petrol used. Work out the upper bound for the petrol consumption for Katie's journey, given your answer correct to 2 decimal places. So what we're going to do here is look at this format of the number. So 238 is a whole number, so I'm going to treat that as 1. So we do 1 divided by 2, which is 0.5. So to find the upper bound for 238, we do 238 plus 0.5, which is 238.5, and the lower bound is going to be 238 minus 0.5, which will give me 237.5 respectively for the lower bound. Now for 27.3, I'm going to treat that as a number that's been rounded to one decimal place. So we do 0.1 divided by 2, which gives me 0.05. And then we do 27.3 plus 0.05, which gives me 27.35 for the upper bound. And then we do 27.3 minus 0.05, which gives me 27.25 respectively for the lower bound. So now that I've got that, I want to work out the upper bound for the petrol consumption for Katie's journey. So the upper bound of the petrol consumption So that's going to be the upper bound of the miles traveled, which is going to be 238.5 divided by the lower bound of the number of litres of petrol used, which is going to be 27.25. And then we're going to round this solution to 2 decimal places. So it's 238.5 divided by 27.25. That'll give me 8.75 correct to 2 decimal places. So 8.75, and I can write to 2 decimal places.